Do you think you would ever go to space?
I would really like to. I mean, that'd be really cool seeing all the stars and like the moon in person.
How many stars do you think are out there?
I'm not sure. I once tried to count them, but I only got to like 120.
Do you think there's war in space?
I'm not sure. Maybe, but who knows?
Do you think humans will ever live on Mars?
I think if we get really good at like making kind of like a bus to space, we totally live on like Mars or like anywhere where there might be like water.
Yes, water is very important. That's impressive you knew that. Okay, and last question. Why do you think we humans want to go to space?
This week from Microsoft is the release of Internet Explorer.
Amazon.com's total stock market value surged past $30 billion.
Struck a deal with eBay to sell a company at about $4.5 billion.
The first glimmers of hope were right after the dot-com bubble. You had individuals realizing that NASA was not going to do this job, so we're just going to have to do it ourselves. So this was in 2002, and I was still a kid student at Purdue, and the professors announced that this new dot-com millionaire that nobody had ever heard of was going to come visit class and give a pitch on his company. That person was named Elon Musk, and the company was SpaceX.
SpaceX and Blue Origin come around almost at the exact same time. And here's the idea. We're going to try commercial space all over again.
One of the things that was going on at the time was this prize for the first private human spaceflight. It was called the X Prize, run by the X Prize Foundation and a guy named Peter Diamandis.
Once we have private spaceships that can do this thing affordably over and over again, we would offer this tremendous frontier to benefit humanity here on Earth.
What Peter did was he realized you need a whole ecosystem of companies and you need a lot of people trying to do this hard thing if you're going to have any hopes of a small number actually breaking out and doing it. Just like with Charles Lindbergh and the prize that he was going after, the X Prize cost hundreds of millions of dollars to be invested into this whole array of companies all trying to do it, or even if they didn't end up going after that prize, do something along those same lines. So it was just a massive boon to the industry, and that's where we really started to see things take off.
You seem like you like space.
I mean, of course. I first met Elon Musk in 1996, which is a long time ago. Now it may seem obvious, like, wow, what a great business opportunity. But back in 2008 and 2009, it was anything but. No venture firm had space as an investment category. It was our largest investment to date and one of the boldest, most audacious projects we've ever seen. You might find this amusing, but there was never a PowerPoint pitch or pitch deck, frankly, ever. And so it was a discussion. And Elon, in describing the opportunity, really focused on the near-term opportunity to do commercial cargo for NASA. There was a contract. It was worth billions of dollars to supply the space station. It was really the first bet the government was making on a commercial provider for launch. Without that contract, it would have been a very difficult proposition to fund. But what we saw was an opportunity to really restructure an entire industry that hadn't had new entrants for decades. And to do so dramatically with a software-centric, high-tech oriented approach that immediately struck us as something that could revolutionize the entire space industry and open up new vistas that weren't even possible before, like to launch disposable satellites and huge constellations and mega constellations. All that was to come. Step one was lowering the cost of access to space, and we saw SpaceX as that a key enabler. So you had like an amazing entrepreneur, a unique, one-of-a-kind company with no direct competitors, and frankly, a prize, if you will, that's enormous, which is the entire space economy.
2, 1.
I'm Ashley Vance. I'm a journalist and author. I've spent many years covering the rise of commercial space. When the first time I went to visit SpaceX, it was like a religious experience, sort of. It was just so different than what I expected. I expected to see like one rocket and like 20 people working on it, and I walk in and already, even in those pretty early days, there's all these rocket bodies along the floor. There were hundreds of people. There was like heavy metal music playing, people welding. You could just feel this energy, and it was so different to what I had pictured in my head, and it felt so real. Like one of these things where you're like, do people know that this is happening? There's this one level where SpaceX just had to prove things out and show people that commercial space could be real, and they did that with Falcon 9. It became this like steady launching vehicle. Still, even in traditional space, and the naysayers, they still thought SpaceX was a joke. They thought things like reusability would actually be the undoing of the company, that Elon would spend himself into oblivion trying to chase this both like impossible and pointless exercise.
Breakthrough that's needed with rocketry is a truly reusable rocket. You know, if we're to make a revolution in space, it's got to be reusable. If you think about any mode of transport, bicycle, plane, everything.
It's just too expensive to, have it disposed of.
Exactly. Yeah. And thus far, it's been an elusive dream in space to create a truly reusable rocket. This is tough.
Hey, I'm not an engineer, but I can tell that's complicated.
There was a launch of what was called the F9R, the F9 reusability. This was the early days before any rocket booster had come back to be reflown, and many in the industry thought it couldn't be done. And we were there. It was going to be a 3-engine test. They put in some new navigation system, and it went haywire, and the rocket sort of tilted over, and they had to do a detonate, and it just made this enormous kaboom because it was, pretty heavily fueled, and it spewed wreckage everywhere. Quite a scene. And I actually suggested to Elon, hey, let's go out there and look around. And as we're driving out, we get a call from someone who's quite nervous about this. And we decided to just keep going. And it was amazing. We're like seeing the aftermath of this, ambition that had a setback, right? And one of the other board members was trying to cheer Elon up and said something to the effect of, you're not learning if you're not failing, or something to that effect. He goes, considering the alternatives, I'd rather learn from success.
One of the hardest things I've ever had to do is get the liquid oxygen densification program running. So Elon coming in and saying, we're going to densify liquid oxygen to its triple point. I basically want solid oxygen on the rocket. Go make it happen. Only C I've ever gotten in my life was in thermodynamics. So of course I get handed a thermodynamics problem. And that tenacity to go turn that around and make that happen. If I wanted to go get sent out to NIST to go learn something, or go talk to some other expert halfway across the world, I was given those resources to go figure it out. The first densified propellant launch. It was impressive to know that everyone at that McGregor test site put so much work into that program. And the immediate thought was, it seemed impossible and daunting, but it was way more exciting to know that we just completely changed the way people think about launch.
If you fast forward, once Falcon 9 starts to hit its stride, then they start landing the thing all the time. They're getting up to Falcon Heavy, and even like larger version of this. And the whole landscape has been flipped on its head. This thing that was supposed to be impossible clearly works. Traditional aerospace is like still reacting to this. I mean, they had no backup plan from anybody else, and they're still 10, 15, 20 years behind because they haven't even started to design a competitor. And then if you flip to new space, these new economics are locked in everybody's head that can and should approach this all differently than we used to.
SpaceX raised $1 billion in 2015. That exceeded all prior venture investment in the space category throughout all of time, times 2. And from that point on, billions of dollars have been invested every year in the category. All kinds of new launchers and satellite companies just cropped up everywhere. Hundreds of companies cropped up.
I would interview all these people, and they had all grown up watching the Apollo program, and this had been part of their childhood. It had fed their enthusiasm, their interest in engineering, and that had just been killed over the years of space really not changing. And all that energy, that passion was unlocked because there was a new game in town, and commercial space felt real, and everyone wanted to have a crack at it, and I wanted to watch.
Right now, telecom and Earth observation are the only two industries that you can really make a buck in space besides the transportation itself through rocketry.
The default thought 10 years ago was that there's a business in launch that's worth a few $1 billion a year. There's a business in communication, and there's business in Earth observation, and all the rest is kind of up for grabs. And it certainly seems to me that that observation holds true today.
From like the 50s when we first started putting satellites into space until about 2020, the sum total of satellites in low Earth orbit was roughly around 2,200. Every year you'd be lucky to put up 50 or 60. Over the last 3 or 4 years, we're on this exponential curve now. So we've put up thousands upon thousands of satellites. We're up over 10,000 in low Earth orbit now. So this is like a huge dramatic shift. I mean, this would have been like unthinkable even just 5 years ago. Now there's more of an era where you can buy a cheap rocket from a company like Rocket Lab. They're getting to the point where they're launching about every 2 weeks, every week, and you can get your own spot on that rocket and get put directly into this orbit you want to go to. You can basically buy it with a credit card online and order your launch. And then there's SpaceX, which it gives you this much larger rocket. And they do these rideshare missions where different satellite companies all buy space on this shared rocket. Now you can just hitchhike a ride on this rocket with a bunch of other satellites, all share the cost, and get up for hundreds of thousands of dollars.
So other launch providers will charge you what they think you can afford. We believe in everyday low prices.
We flew our first satellite on a Falcon rocket, and then that wasn't enough, so we went and got our own dedicated Falcon 9. In fact, we have two. And that would just never have been possible for a company like ours to be out buying our own dedicated rockets, with no government assistance. That would just be unthinkable 20 years ago.
You get from this era where getting to space is rare, expensive, precious, to something closer to like a commodity.
And it turns out, no matter who you are, when there's a rocket launch, everybody's just a big kid, right? Everybody's super excited to see this thing go up and give high fives and give handshakes. Everybody feels like they're pulling together in this space where we're doing new things and seeing what's next in this new frontier.
Getting these launch costs down has just enabled this huge array of new applications by small satellites and done by all new companies. And that is just a huge sea change from how anything ever was before.
Building the satellite that's 30 miles wide that can stare down at the planet and can build a real-time 3D map of the world.
There's so much that we could be doing. It's kind of insane. Like, we could be preventing wildfires. We could be more efficient with our water use and farming and feed more people around the world. I think the potential for taking care of our planet, for security around the world, for prosperity across different areas of learning and health and industry is really enormous through space.
You had companies like Planet Labs. They make these tiny shoebox-sized satellites. They proved you could use consumer electronics pretty readily in orbit. You could change the size of satellites. You could have a plant in San Francisco where you're mass manufacturing these things instead of it being $1 billion precious object that takes 10 years to build and is meant to stay in space forever. You put up these modern computers and you let them fall back and you replace them.
When I joined Planet, the mission to image the Earth's surface every day. And that required obviously putting up a lot of spacecraft in order to do that. Planet was really, I think, one of the key companies at the time that was really on the one end of the spectrum of let's launch things and test it in space and just sort of go fast.
We've already seen people like Planet Labs rethinking the entire concept of what a satellite could be. There should be more of those. I think there's still a whole bunch of opportunity there, or other constellations that are allowing us to look at the Earth more powerfully than ever before, not just optically with imagery, but with radar images that measure distance and LiDAR and a bunch of new things that are coming down the pipe for ways to understand our Earth and what's going on it.
So SpaceX was the next company that immediately took this constellation idea and blew it up even further.
Starlink itself is just an incredible business opportunity that was made possible by lower cost of access. To say, what if we flew thousands of satellites in the place of single ones before that give us constant access for broadband?
We have these Starlink antennas. You think of it as like you're just getting high-speed internet in some remote location. I think of it in this totally different way, where it's blanketing the Earth and creating this type of fabric. This global communication layer, which space will be the main driver of, will be a huge deal. We're around 10,000 satellites now, 6,000 of which are Starlink satellites. I think we get to 100,000, 200,000 over the next, I don't know, call it decade, 15 years.
Connectivity with space is still stuck in a different era, so a lot of satellite companies accept outages and blackouts in a way that would be completely unacceptable in another industrialized sector. What we're doing is trying to reset those expectations for the space industry to say, no, if you want to industrialize space, the baseline should be that satellites are by default always online. So we help satellite companies send data to support global connectivity, which we believe is an important underpinning factor in being able to industrialize the space economy. The key demonstration point for what we're building is showing that we have a more efficient technology to communicate with satellites. That technology is phased array antennas. Okay, we're less than a minute out now. 10 seconds.
All right, we are tracking.
Oh yeah, look at that hump. You guys, look. Yeah.
Yeah, nice. All right, we got it. Cheers.
Northwood. To Frankie.
One of the cool things and difficult things is that, we're operating in an environment where a very tiny fraction of humans have ever operated or have any experience in.
So at Varda, what we're working on is manufacturing pharmaceuticals in microgravity. What does Varda actually do to achieve that? We build spacecraft that have pharmaceutical payload manufacturing modules inside, ship them up, they manufacture, we then do a re-entry and bring a capsule that you see there back to Earth. And inside is a new pharmaceutical formulation that we can then provide to the customers. The personal transition from a SpaceX engineer to Varda engineer was very seamless. So it's like, here's a rocket that all the buddies in the room right now helped build that is deploying our new spacecraft that is being filmed by the camera I designed. It's like, you couldn't design a more fun experience in engineering than that.
So one of the other things is orbital mechanics. And how do you get into a orbit? How do you stay in orbit? Things like that. How orbital mechanics works is actually quite counterintuitive. It's very different than if you get in a car and start driving. You go point that direction, you accelerate. In orbital mechanics, that actually affects the opposite side of the orbit, not where you are right now.
The most common misconception I've found about engineering in space is thinking that space and orbit are the same thing, and they're just vastly different.
3, 2, 1.
You can get to space with a hot air balloon and a natty light can and a GoPro, and you can YouTube those 3 words and you will see a natty light can go to space. That's a little bit trivial. Anyone can do that. Getting to orbit is the tough part. Imagine yourself running off of a cliff and jumping as far as you can. And now let's say you ran a little faster. You could get farther at the end of the cliff. Now just imagine that thought experiment over and over again where you're running faster and faster off the cliff. You're gonna land farther and farther out. Now imagine you take that to the extreme and the Earth's surface is round and it starts to curve out from under you. So that's what orbit is you're falling still, but the Earth is curving out faster than you can fall, and that's orbit. So you gotta be going bananas fast. So you're going 17,000 miles an hour just by being in orbit. You're going Mach 25. To get to space with the natty light can, you don't have to be moving at all. That's just about altitude. But the key concept here for gravity is that when you get to space and you're not moving, you're not in free fall. It's actually free fall that eliminates gravity. It's not just being high up.
There's just so many things that can go wrong. You're launching into space on a rocket that is very, very loud and it's vibrating like crazy. You're in the middle of nowhere in space, you don't know where you are. You're depending on computers to do autonomous control. By the way, those computers are being bombarded by radiation that causes them to break, stop working.
So you've got the sun, massive fusion reactor, putting out a lot of charged particles and what's effectively gamma dose. Secondly, you've got supernovas. When they explode, they put a lot of particles of very high energy.
The Earth's magnetic field shields a lot of those radiation particles that would otherwise hit Earth. But if you're up in space, then you have to have electronics that can deal with that radiation. You have to have chemicals up there that can deal with that radiation.
Whether it's just basic upsets that you get, or whether it's these big heavy particles that just like blow up your device. And so we have to protect against all those different things in a variety of different ways. You've got extreme temperature ranges. What's actually crazy is because there's no atmosphere in space, temperature isn't really a thing. It's really the temperature that your spacecraft is. And furthermore, you can't design it to work with convection or anything like that. And so being able to work in a radiation-based environment. Relatedly, one of the common myths of space is cold, so it must be easy to make things cool. Not actually true. When you don't have air flowing around you, actually things get very warm. And the sun is always pointing at you, or you're pointing at it. And so that tends to also keep you warm. So actually keeping things cold is difficult, especially for a power-hungry payload like a telecommunications spacecraft.
To stay up there in perpetuity, you've got to be in orbit. And if you're in orbit and you're going that fast, that means in order to come back, you got to dissipate a crap ton of heat. It's something like 2 million hot air dryers on for about an hour of the amount of heat that you need to dissipate in the 10 minutes of going through re-entry. That's kind of the extremes of space engineering.
Also, you're really far away. So, your ability to talk to the thing, you have to close a link over something that's pretty far away. And probably the biggest of all is you can't service, you can't maintenance something that's in space. So you have to design it so that no matter what happens, it'll be able to get into some sort of safe mode that you'll then be able to talk to it, because you don't have that ability to go, oh, no, that little thing is wrong. I'm just gonna, turn that bolt and fix that. You need really all of the things. You need all the disciplines. You've got mechanical, you've got electrical, you've got software, RF, you've got like many different subflavors of all of those different things. There's manufacturing. How do you put it together? One decision in one particular thing could impact so many other ones. And so, we have to have all our teams really tie very closely together.
Historically speaking, operating in space has been such a constrained environment that it kind of makes engineers go crazy. Okay, you want to put a robot on Mars. Great. Well, your mass budget is laughably tiny. Your power is also constrained. You have less than 100 watts of power, which is not really even enough to light a standard light bulb. Your data is constrained because Earth is 100 million miles away. Materials are constrained because of the corrosive environment. Put all these things into your requirements box and shake it around for a while, and it's just nightmare material. It's a miracle these things work at all.
What you'll start finding with some of the supply chain are unique requirements. So sure, we have exotic materials. That in and of itself is hard. Then you have just mass quantities of maybe raw stock copper and things for propulsion components, which you have to start planning years and years in advance for those long lead times. And so these downstream effects of having rare materials or unreliable vendors drives a lot of new space companies start saying we need to be vertically integrated. Our founder knows that we had to have not just vertically integrated, but everything is co-located. So now I don't have these delays while we're going to California, to Texas, to the Cape, back and forth. I have my machine shop right next to me, next to my test stand. So I'm gonna build it right here. I'm gonna have the engineer here with the technicians. So if work instructions aren't clear, you can pull them to the floor, and then you go out and you test it, you break it, you bring it in, you analyze it, and then you go and you build it again. All of that happens in the same footprint. And so it starts as a supply chain problem, and then you realize you're vertically integrated and you start setting up for success in that way. When you don't have all of this additional infrastructure, engineers are doing 100 different jobs. And so you might be burning people out and you don't feel like you have that amount of support. I think that's something we're really struggling with. And you also have a workforce that doesn't want to stay in the same job. There are far too many people who I thought were phenomenal that dropped out way too early.
There's one pretty crazy thing when we were just, building these different deliveries, batches of spacecraft that we were launching. We spent a couple of really hard weeks getting 26, I think it was, spacecraft built for a particular launch. And we got them delivered, and then we had launch.
4, 3, 2, 1.
Went off the pad, basically just barely cleared the launch tower, and then it exploded. What was kind of crazy was that it wasn't that far off the ground, and CubeSats are put into basically missile launchers. It's like super armored Titan case. And so the thing that exploded was the fuel tank, obviously below the payload, and deployers got pushed off and ended up on the beach. Then they ended up deploying out of the containers, and a bunch of them were just sitting there, like waiting to be talked to. They thought they were in space, they were not. And then they, closed them back up and shipped them back to us. And we then pulled them out, and crazy enough, I think every single one of them actually talked to us. Pretty mind-blowing. We were able to negotiate and get a last-minute slot of being able to get 2 spacecraft on one of the upcoming launches. And the catch was, you've got like a week and a half to do it. Fortunately, we had a bunch of piece parts of spacecraft, and we were able to throw that together. And when they got up, we got the data we needed.
All engine running. Liftoff. We have a liftoff. 32 minutes.
We assumed that it was governments that were going to take us to Mars. It was governments that were going to take us to space.
Liftoff of Curiosity, seeking clues to the planetary puzzle about life on Mars.
We will increase investment in other groundbreaking technologies that will allow astronauts to reach space sooner and more often.
Now that has been completely turned on its head. 4, 3, 2, 1.
New space is a new era of space that's moving towards industrialization and greater capabilities and activities through space that serve humanity in a wide variety of ways.
Getting to space is now easier, right? So there is reusable rockets. They're at a much higher cadence and reliable. You could think of new space in one way as businesses that are now enabled because that fact is now true.
It's the contractors in some ways, and the companies defining the design, the mission, and the vision, not the government.
We're seeing more and more ideas sprout and grow and germinate faster and faster and faster. And this is only accelerated by low cost of launch, low cost of hardware. This kind of explosion is happening just at the right time.
We started a company 30 years ago. It was madness for us to start a company at that age then. People were like, "You're doing what?" Now it's completely normal. It's expected of you to be a space entrepreneur in your 20s and 30s.
We do things fast, we do things cheap, we bring the benefits of space to people in the world.
One of the mantras that my co-founder really instilled into the company was that at Varda, the trains take off on time. We may not have all the passengers, the train may not be as fully featured, but it will take off on time. Because actually the important thing of being a successful space company is just building the muscle to just be regularly flying hardware to space.
If hardware is on the ground and you're in the aerospace industry, you're losing. But if you can get it off the ground, you have a chance for success. Before SpaceX, it was largely government contracts, so cost plus, and that filters very quickly to the engineers of, hey, what are we trying to optimize for? And that's different in a world of fixed firm contracts instead of cost plus contracts. So you're incentivized to win, take a little bit more risk, because every dollar you save, you keep, whereas in cost plus, that's not necessarily true.
One of the easiest curves to study is the total mass that humanity sends to orbit. If you look at it from 1969, let's say, till roughly 2012, it actually was effectively flat. And then 2012 to today, 12 years later, we've actually basically been following a perfect exponential curve. Very fun to get to be in that crux of the curve where for the first time, sort of really ticks up.
Really the ethos of new space is moving fast, delivering things, even if there's a higher risk than some of the things might fail.
I think it's easy to boil down what new space is with a risk posture, but what you don't see behind the scenes is this culture and this environment that's okay to ask a question and challenge your boss or your boss's boss.
All of these companies have completely changed not only how we do business in space, but how we think about doing business in space.
We're suggesting that you...
yeah, but he could remove it and replace it.
The CDR is still working on it. Just sample the mark.
The Apollo era was this unique moment in history where all of the top talent across almost all of engineering was being drawn into this one thing. You knew you were going to get to build super cool shit, and you had a blank check from the United States federal government just spending whatever it took.
If you reverse back to the Apollo era of humanity's first real step into the stars, while an incredible feat in history, because it fundamentally was not private market driven, was not a sustainable effort. It did pull forward humanity's capabilities significantly. In some ways, I would argue landing a man on the moon in 1969 was literally for the first time possible in 1969.
Sure, it took them a ludicrous amount of the national budget to do it, but the things that they were able to accomplish very quickly was very impressive.
Well, the Air Force and NASA were launching at least like a rocket a month. And in the beginning, most of them are just like blowing up left and right. They didn't care, slap another version together, put it back on the pad. You know, much, much closer to what SpaceX is doing today with Starship than any other rocket development effort.
It was at the true cutting edge of what humanity was capable of, and like barely, and was extremely, sort of cowboy and incredibly, incredibly expensive. And that was possible because you had the budgets of a fundamental state government that was not looking for any type of ROI or IRR or return on investment.
I therefore ask the Congress, above and beyond the increases I have earlier requested for space activities, to provide the funds which are needed to meet the following national goals.
I think it was an appropriate thing to do at the time where we had a near-peer adversary, global superpower, communist regime. But in some ways, I would argue that I think the United States somewhat succumbed to a mimetic rivalry with this global superpower, where we ultimately, in some ways, copied their ethos and philosophy. The Russians were taking a top-down, state-driven approach to landing a man on the moon and conquering the space race. And so how did the United States respond? We responded in kind with an identical approach. And in all other aspects of the United States versus Russia in that time period, we were entirely orthogonal to one another. The one area where we perfectly copied one another was the space race.
These rockets meant everything. You've got the race to create the first satellite, you've got the race to create the first spy satellites, then to get rockets up into orbit, and then people up into orbit, and all these things were so wound up in national pride. And then especially when you get to people, the rockets just cannot fail. This has to work. Obviously you have lives on the line, but there's also this Russia versus the US, this pride that goes with it. And so things just got stuck.
There were many years of the shuttle era, which really felt like the space program was going nowhere, and it really was going nowhere.
The problem was you had this combination of winning the Cold War and no longer needing to spend money on space in that way, paired with the space shuttle being far more expensive than they ever thought. They ended up estimating the space shuttle cost $1 billion a flight. That, unfortunately, just sort of sucked all the oxygen out of the room and led to this great stagnation in the space industry. And it was just incredibly hard to break out of that.
You had this massive pull forward of humanity's capabilities in space on this previous curve that we were originally on, and instead we've now fallen back onto that curve. And naturally, when was humanity actually supposed to reach the moon? It probably was roughly in the 2020s, and you're starting to see that to happen.
People had tried to get commercial space going before in the 90s, kind of bleeding into the 2000s. It never worked that well.
We invite you to join us on a voyage to the future.
Our company will be the first venture focusing on the low-cost commercial delivery of satellites into low Earth orbit. And we will do it without relying on government funding.
People would get so far along and then more or less give up. NASA always reared its head as a competitor and would kind of squash things down. "20 years ago, I would say the US and Russia were the dominant forces in space, but China was already launching quite a bit, maybe about like 12, 14 times a year. Fast forward to now, China is the clear second player, and they're launching about 40 times a year. They have a very ambitious space program. They're doing satellite launches, they're doing military launches, they're flying missions to the moon. They have their own space station, and SpaceX had not arrived in the last 20 years. China would be the clear space superpower.
What we're seeing from China is they are deploying capabilities in every orbit. They are launching LEO constellations. They have their own GPS system that is actually multi-orbit, unlike ours, which is just in one orbit. They're launching secret space planes. They have comms infrastructure in GEO. They have everything you can basically imagine.
Chinese satellites have been known to pop out little baby satellites that then go inspect, other satellites in orbit, and exactly what they're doing isn't clear, but you could see this as either sort of espionage on the satellites or like an anti-satellite type operation. You've got countries like both India and Russia that have shown they can launch missiles, from the ground and take out satellites in space.
When you think about the potential for military conflict, space is just of absolute critical importance. By definition, if you have a conflict happening out on a battlefield, there's no fiber that you're tapping into. There's no just coffee shops with Wi-Fi. You are getting your broadband connectivity from space. That is what the military does today. That's what it will be like in the future. So the prospect of a war in space that starts to destroy satellites, destroy those capabilities, that is just a situation we cannot afford to have. As things stand today, the U.S. is actually very dependent on a small handful of giant, very expensive satellites. And it would only take a few of those getting taken out or there to be a massive disruptive effect across the entire U.S. military.
Russia is developing a nuclear anti-satellite weapon intended to be placed in orbit in outer space. This crisis is the Cuban Missile Crisis in space.
I think the huge concern is if this gets out of hand and you start creating a ton of debris in space, there's this thing called the Kessler syndrome where one satellite gets destroyed, it starts running into all the other satellites and you get this cascading effect. Then low Earth orbit becomes unusable. We're more or less trapped on planet Earth until we figure something else out.
The answer is resiliency, right? The answer is swarms, just like with drones, but in space with satellites. And just remove that temptation entirely. Because if you have dozens or hundreds of satellites that they would have to take out in order to have an impact on your capability, they will be that much less likely to do that. There is a new space race happening right now between the US and China. That race is to get back to the moon and lay claim to deposits of ice that are at the lunar South Pole. These pockets of ice are incredibly valuable, making that real estate the most valuable real estate in the solar system. China just launched a lunar probe that landed at the lunar South Pole and demonstrated all the technologies they would need to do a follow-on mission with people to actually start exploiting those resources. So my concern is China's going to beat us back to the moon. They're going to set up a permanent base and they're going to say, this land here, this is ours.
Part of my motivation for working on Varda is the prosperity that we can bring to humanity. But a part of it is I am a proud patriot that lives in the greatest country on earth. And I believe that our fundamental democratic values are what are best for all humans and the future of humanity. And a part of why I wake up to work on Varda every day on earth, that's that one day the primary language spoken on the moon is English, not Mandarin. And that has less to do with the cultures and languages, it more has to do with the fundamental government regimes that are behind those. One, respect human rights the most in our democratic republic. And on the other side, you have a genocidal authoritarian dictatorship that is looking to censor all its citizens and control how they think. And I think that is incredibly critical that we succeed in space because space is the ultimate strategic high ground. Space is the ultimate frontier.
It is not enough to merely have an American presence in space. We must have American dominance in space.
Space Force At the simplest level is this other branch of the military. In a lot of ways, it's a very old idea. Since like the 50s and 60s, there's been generals that dreamed of being able to like push a button, launch a rocket the next day, put a satellite over a country where you have a conflict so you can watch everything that's going on. So I think in some ways it makes a lot of sense.
The U.S. Space Force wanted to find a rocket provider that could turn around a mission in 24 hours. The last record was 21 days. So 21 days down to 24 hours. It absolutely looks easy, but behind the scenes, there was so much training and so much prep. These folks on these teams, not just Firefly, they live and breathe aerospace and these types of missions. So they've done this, they've worked at SpaceX, they've worked in the military. And so like we have decades of experience with each individual providing their own insight in how to make this the best well-oiled machine that you can see. From a national defense perspective, I think one key element that the U.S. Space Force is excited about is this military deterrent aspect of it. And so if there is a security threat, not only do we have this 24-hour get a call from the Pentagon, launch a mission capability, but it's this entire suite of launch and on orbit that the U.S. Space Force is really trying to get a foothold in and continue to expand.
There's clearly a whole camp of people that have not wanted us to weaponize space, not make all these mistakes that we've made on Earth in space. For them, the arrival of Space Force is probably a negative. I think it's probably it's a reality that space had already been militarized and weaponized, long before. And so this is just a new branch of the U.S. military.
It really should not be possible to build a giant rocket faster than the paper can move from one desk to another.
We will plant the stars and stripes on the planet Mars.
I mean, can you imagine how awesome it will be to have American astronauts plant the flag on another planet for the first time?
Jared Isaacman, a tech billionaire who flies fighter jets, commands private space flights, is President Donald Trump's pick to be the next NASA administrator.
Why does this mission of going farther into the stars matter so much to you each personally?
I remember, I think it was in elementary school, maybe fourth grade, it was like a geography 101 and looking at a map and actually a sense of disappointment that they already discovered everything. Like all of the explorers found every island, all the mountains, and I was like, there's nothing left. And then, you grow up and get fortunate to have an opportunity to go out in space and realize we've only just begun. Like we have literally just dipped our toe into like the grandest ocean ever out there. And we have no idea what we might find, what we might learn that could completely change the trajectory of humankind back here on Earth. And we could be 3D printing organs in space. We could discover new minerals that unlock a new form of energy here on Earth. We could make life multiplanetary, which seems like a really good thing to do when you think about the fact that throughout Earth's history, there would have been several extinction level events. If we weren't born at the right time to evolve at the right place, and now we actually have the technical means to go out and do it. So it feels like it's an obligation, and we were really just lucky to be a small part of it.
How cool would that be if our kids have an entirely different relationship to the conversation than we did? Because it's not 600 people, it's thousands of people that have made it there. That would be incredible.
I love space, and I feel like we have this huge obligation to pass that forward and to share not just space, but what humans are capable of doing with the next generation to inspire them and to see where they can move us forward as humanity.
Any opportunity is extraordinarily precious at this point.
That's not where we want to be in the future. We want more people to be able to experience this, to be able to go out and explore, maybe go to Mars and actually make life multiplanetary.
If you talk to a lot of the early astronauts that went to space, there are lots of classic, beautiful quotes about them saying how, they thought they were going to space to really conquer the unknown, and instead, they discovered Earth. It's a really interesting perspective to go to space, turn around, and look at our home planet from the point of view of it being this little tiny ball that is hurtling alone through space, with us, the human population, all together living on it. And so as I think about us going out into space, I think about as much going and finding other places to live, going to asteroids and bringing back materials for us here on the planet, as it is about us having a very different viewpoint about our own planet.
Oh, it's going to be incredibly hard and risky. All new frontiers are. And I think that's part of what inspires generations to do things.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Heroes are a very important part of our culture. Astronauts, people of that profession, are by very definition heroes. Who doesn't want to grow up to be an astronaut?
We set sail. We ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked.
The direction of the President of the United States, it is the stated policy to return American astronauts to the moon within the next 5 years.
And liftoff of Artemis 1, we rise together back to the moon and beyond.
People want to get back to the moon. They want to do cool stuff again. I mean, it's been a really long time. We got to the moon. It was like we forgot even how to do it. And so I think this is exciting that people want to get back there again. All that stuff had really died. It was just like pipe dreams. And so at least we can see the government move in that direction.
Why should we go to the moon? Because it is there. It's just such an obvious place to put a base that then you can use to support further on exploration. And specifically, that's because we now know that there is water in the form of ice on the moon. And ice is many things. Ice is oxygen you can use for air to breathe, and it's also rocket fuel. And that makes it this ideal way station.
Well, what do I want to say about Artemis? There's good bits and bad bits to Artemis. I mean, you're borrowing from a lot of old space, which just does not seem to have adjusted to the new era at all. They're not reducing costs. They're still slow. Things don't always work. And then you're trying to marry some of that with what companies like SpaceX can do. And I'll be very curious to see how the next few years play out and how that balance holds.
It's become quite clear in the last few years, unfortunately, that the SLS and Orion programs are so horrendously expensive and so wildly off track that they are having spillover negative effects on the rest of the space industry and on the rest of NASA. The main contractor, Bechtel, who is building the third mobile launch tower for the SLS Block 1B, is on track to spend $2.7 billion by 2029 on a steel truss tower that was originally meant to be $380-something million and delivered by 2023. And because of the way the contracts are written, NASA can't do anything about it. They can't even meaningfully deny Bechtel their performance bonuses. So literally, this organization, Bechtel, has bamboozled, with NASA's management complicity, the US taxpayer out of billions of dollars. $2.7 billion for this tower is more than the total value of the contract that SpaceX was awarded for the human landing system, for the entire damn rocket that's meant to take the people and all their cargo down to the moon and bring them back again. And meanwhile, SpaceX, of course, has built multiple launch towers seemingly in an afternoon. We really have to ask ourselves, why are we spending $5 billion a year on this program for 20 years with nothing to show for it? We should cancel it.
Just after midnight tonight, a SpaceX rocket is due to lift off, carrying a pair of commercial landers that will try to touch down in the coming months.
I mean, it's absolutely huge for me, right? Especially because the first memories I have are around Apollo and around moon landings, and our photos of the moon landing. Everything is about the moon. And I grew up in Houston, in the same neighborhood as Neil Armstrong, Buzz Aldrin. Here I am, 3 years old, and I'm flipping through my dad's scrapbooks of awesome people and pictures of the moon. And then all of a sudden a check. And I'm like, Dad, why is there paperwork in this awesome scrapbook? And he loved Neil Armstrong, Buzz Aldrin, and all the excitement that went with that. He was a paper boy in the neighborhood, and he was way too embarrassed to walk up and ask for their signatures. So he saved up the $2.12 for their monthly paper and paid for it himself, and then just pocketed the check. So we have Neil Armstrong's signature and Buzz Aldrin's signature on checks. We have 10 different payloads that we're bringing. We're doing everything from drilling to analyzing regolith to what are the dust interactions? It's a huge issue that comes up in lots of questions. And so it's going to start with small little experiments and capabilities like this and just continue to expand to have an entire cislunar and lunar economy. And so you'll have on-orbit communications in lunar orbit, in Earth orbit. You're going to have this much larger and much more capable infrastructure and economy beyond just the Earth. It's really hard to believe over decades of thinking about this, and every piece I put together to be a part of something like this with this team. It's finally here, and it's surreal, and I'll be on console for that mission. And I think if you shot me a text an hour after that, I'm not sure I'd have words.
3, 2, 1, ignition, and go. Vehicles pitching downrange. Firefly Blue Ghost, separation confirmed.
From all of us here at SpaceX, it has been a pleasure having you on board, Blue Ghost. Safe travels.
It's wild that we're basically on a sand spit by the Rio Grande, and that is actually the gateway to Mars. So we want Mars to be a self-sustaining civilization as quickly as possible. I think this can be done in around 20 years.
The reason to go to Mars is that it is the closest thing we have to a twin planet. It's not perfect, bit of a fixer-upper of a planet, but it's just the best we got.
Earth and Mars are relatively close to each other about once every 2 years. And so the goal for SpaceX with Starship is just want to be firing off as many Starships as you can in these windows. And first, obviously, to get cargo, industrial type things, and then humans that can go visit and then hopefully come back.
There is something of an open question as to exactly how much stuff and how many people you need in order to bootstrap a Mars city to be fully industrially independent. It is almost certainly more than 1 million people and more than 1 million tons of stuff. And then the question is, once you're there, what do you do? How do you start to build a city and figure out how to bootstrap from the first 100 tons to the first 1 million tons of stuff there?
In situ resource utilization, something that you might hear a lot about, and that's how do you not bring everything up from Earth, which is highly inefficient and undesirable in a lot of ways. And so both the acquisition of these resources, whether that's ice or whether that's metal or whether that's lunar regolith or things like that. So how do you acquire it? How do you process it? How do you build it?
Ultimately, we'll need lots of power generation, mining in general, propellant production, long duration life support, a lot of construction, and then global communication. This would open up a lot of opportunities for entrepreneurs that want to create things on Mars.
So some things for life in space is a little bit different from life on planets. Some of the solutions do involve physics, but for some reason we've never implemented them. There's low gravity and high radiation, and they both have physics solutions and biological solutions. So for physics would be to centripetally spin the spacecraft, and then you create artificial gravity. And then for radiation, if you have a magnetic field plus dense material equivalent of about 10 meters of water, that's equivalent to our atmosphere, and that would produce radiation. Or we've found ways that we can improve radiation resistance, sometimes 10,000-fold, maybe more, and that would be possible. For microgravity, it's not really practical to have a bunch of centrifuges operating on the planet. It might be practical for, in space or if you're on long missions. So on the planet, it might be better to address the medical consequences, fluids going in the wrong place and osteoporosis and things like that. Right now it's overwhelming the amount of exercise that people have to do and the amount of food they have to eat to compensate for the amount of exercise they do. We know enough about the biology that we could start making inroads into how we could be adapted for microgravity and radiation.
My name is Erica De Benedictis. I'm the founder of a startup called Pioneer Labs, where we're trying to use engineering and evolution to make microbes for use on Mars. Mars is pretty much the combination of basically every way that we usually kill microbes. Individually, we can find organisms on Earth that can tolerate any of those extremes in isolation. And what we don't have is an example of an organism that can tolerate them all together, and I want to make that. We're using a process that's very similar to cultivating roses or breeding dogs called directed evolution. We're trying to take microbe A that is really salt tolerant and microbe B that's really tolerant of low pressure and smush their genomes together so that you get something that's both. And indeed, if you want to deploy biology towards something that it's really good at, which is scale, the scale that it works really well at is a planet. And in fact, on Earth, we've seen this before. So Earth didn't used to be habitable by humans. It didn't used to have oxygen in the atmosphere at all. And it was the arrival of microbes that changed the chemistry of this planet at planet scale because photosynthesis started happening and microbes started converting water into oxygen.
At some point, we're just going to have to terraform the planet. We're probably a few centuries away on that, but it is doable in the same way that building cathedrals was doable in the Middle Ages. That was an effort that took far beyond the lifetime of any one craftsman or architect, and they did it anyway, because they knew the end result would be worth it. We're going to have to look at terraforming Mars in the exact same way.
So in terraforming, the question is it possible to do maybe something like what we did on Earth, make it a bit warmer on Mars so that the ice melts and we can have rivers and streams and lakes and oceans and rainstorms, and then presumably plants, and then start to thicken the atmosphere to retain some of that heat and also convert enough of it to oxygen that you can breathe. And a lot of people have thought about this problem for actually more than a century. And the really exciting thing is, I think, through a combination of engineered nanowires and solar sails mass-produced on Earth,
It'd be a little bit like a second moon. Night wouldn't get so cold.
you could actually heat up the surface of the planet to enable liquid water relatively cheaply and quickly. We're talking decades and small numbers of billions of dollars, which on the planetary scale, that's doing pretty well.
The light of consciousness is like this tiny candle in a vast darkness, and it could easily go out. So we want to preserve the tiny light of consciousness on Earth, but extend it to Mars and then ultimately to the rest of the solar system. You can just imagine all of these starships waiting in orbit for the planets to align, and then this gigantic starfleet taking off from Mars.
I think humans have had these fantasies and these ideas of what they would like to do up there, but you really have to have a vehicle that's capable of pulling that off. And Starship is clearly Elon's answer to that.
So the Starship is this deceptively simple idea. It's a world's most complicated high-performance rocket, and it's designed to transport cargo to Mars in 100-ton increments.
Where we are today with New Space ultimately is really because of the dollar per kilogram that has decreased significantly over time. We're coming down somewhere on that scale, but there's a long way to go. And so that's where things like Starship is going to be, unlock even more things.
Starship is this next level of changing the economics of space. Moved from American launch companies charged $300 million per launch. The Falcon 9 got that down to around $60 million. If you believe Elon's numbers, Starship takes you down to about $10 million per launch to put many, many, many thousands of more pounds of things into orbit. And so Starship becomes like this 18-wheeler, even more, maybe like a cargo ship that's just taking stuff to space all the time.
SpaceX correctly recognized that the problem of getting people there is a subset of the broader problem, which is how do you get millions of tons of stuff to Mars? How do you build a conveyor belt, a logistic capacity for delivering stuff to Mars? One of the really exciting things about Starship is that because it has the ability to fire hose mass at the problem, you can trade these problems for more mass. If you're landing stuff on Mars in 100-ton increments, there's absolutely no utility to building a 1-ton Mars rover. You may as well build 10-ton Mars rovers out of steel instead of hogging them out of titanium. The question is, how do you do that as quickly as possible? And first of all, you build the Starbase factory and develop Starships and try not to upset the FAA too much along the way.
I was out at Starbase, spent the night in the employee housing, got up at 2:20 a.m. West Coast time, which is my time zone I was on. And oh my gosh, it was incredible to witness live. For me, there's a vicarious sense of pride in what the team has done. Some of the best engineers, some incredibly long hours and hard work to get the company where it is. And as a friend of mine poetically put it, that moment on that day, she said, wow, a skyscraper just went to space, came back to Earth and parallel parked. That really captures the essence of how unprecedented this is. The rumble you feel, the sonic booms of re-entry, it's just a visceral feeling that captures so much potential energy, literally and figuratively. The potential in that launch and the potential for humanity to go out and live in space and to explore the frontiers of the unknown.
I think of it as like the early days of the internet, laying fiber all around the world, building the data centers that would support the internet. And you put down this infrastructure layer, and then like all the creativity and new ideas come. We're just in the process of like flipping that switch. And so now is like the time when we need new ideas.
Places where space is going to affect human life in the next 5 years, Starlink and its derivatives is one of the biggest of those sectors. Then there's going to be tourism, there's going to be exploration on the Moon and Mars, there's going to be other constellations looking inward and looking outward, great telescopes to understand the universe. But I'm looking forward to entrepreneurs coming up with something that I didn't think of before. Like what might you do with a new generation manufacturing in space, for example?
The bets that SpaceX is making and even the bets that companies like Varda is making are correct. All of what's happening right now is this launching off point to open up this whole new economy that is as vast as the universe, or at least as vast as we're able to travel. Over time, there's no way that space doesn't become a billion times bigger than it is today.
There won't be just a space mission every 6 months. It will be essentially commonplace. And it's going to take so many people that want to be in space, people that are like here on Earth building the infrastructure, the communication, helping solve the medical challenges that will exist, really building that space economy that will even necessitate so many people in space. So the opportunity is going to go from a select few to the many in a very short period of time.
We're going to see a lot more in-space services. So things like refueling spacecraft will become irrelevant. Basically, it'll make it so that all you have to build for your spacecraft is the thing that you actually specifically care about, and the rest of it gets commoditized and provided to you in orbit.
You need on-orbit servicing. You need relocation, altitude raising and lowering and refueling. And so kind of in the same sense that you don't just throw out the car when you get to the store. You already have your satellites. Go figure out how to service them.
that is only the beginnings of the prosperity that sort of space can bring to life on Earth, but to humanity as a whole.
The next big enabling technology will be nuclear power in space. You can use it for power generation, and you can use it for propulsion. And we need both. We have to start making progress on that.
People want to do asteroid mining, send more or less like a robot to an asteroid and have it harvest literally tons of precious materials, like the amount of stuff that would just dwarf what we have on Earth. People want to create giant data centers in space. We have companies that are actually making space habitats now. This also used to seem crazy, but seems real. We just have this bloom of activity taking place on all these fronts that seemed like science fiction 5 years ago.
I think the fundamental thing is nothing is solved. And when people think that they have something solved is honestly probably when they're most wrong.
The interesting part about space is it's almost impossible to have a new idea, in that you can look at catalogs from the late 50s and early 60s of basically every potential new space business model that people are pursuing today that was already articulated by physicists and engineers back then. I did not come up with the idea for Varda, nor did John Gedmark at Astronus come up with the idea for Astronus. We're just executing the ideas that sci-fi writers, physicists, and engineers have theorized about for decades. And so ideation is not the problem. It's when to work on the idea and how you implement the idea that is the much more difficult part of new space.
My interest has always been more about understanding the world that I live in. And if you keep asking why enough times, then you get to the biggest questions in my case. And that's, why are we here? Why is the universe the way it is? Why is it evolving the way it is? Why? So the three main components of the universe is regular matter like you and I and galaxies. And that actually only constitutes barely 5%. And then the rest of it is made of dark matter, which is a type of matter that interacts only through gravity, which means it doesn't emit light, we can't see it. And that represents about 27% of the total matter content of the universe. And then the rest of it is dark energy, and that's about 68% of the universe. So dark energy is the thing responsible for the accelerated expansion of the universe. We've known that the universe has been in cosmic expansion for as long as it's been a thing. Now, this expansion is accelerating, and we were expecting that through gravity. Gravity pulls things together, so we would expect that the expansion would slow down. And the fact that it's actually not slowing down but going faster and faster and faster means that there is something that is driving, that is counteracting the gravitational effects that we were expecting. And that's what we know about it, and we needed to give it a name, and we called it dark energy. We have only one point of view on the universe because all of our observations are done from the edge of a galaxy like this one. So this one is not ours, but it's one very much like ours. And this is only one in a billion of similar galaxies in our corner of the universe. And so really, we're drowned in a sea of vastness. And then the question is, well, would things look differently if we were somewhere else?
Once there are people on Mars and an ongoing market for transportation of people between Earth and Mars, it will create what does not currently exist, which is a strong economic forcing function for the rapid improvement of propulsion technology.
The distance between Earth and the Moon, it's a 4-day trip. The distance between Earth and Mars, 9-month trip. Distance between Earth and the next star, hundreds of thousands of years. So we're just not going to be there with any conventional rocketry.
If you want to do like deep space propulsion for humans, you're going to need antimatter rockets. So we need to figure out how to make antimatter.
And that's relatively nascent physics, especially in terms of containing antimatter, because if antimatter comes in contact with regular matter, it just turns into light and vanishes. And so you got to figure out a magnetic field basically to hold the antimatter without it touching anything else, including the photons in the magnetic field. So it's a very tricky problem.
If you can figure out how to do like an afterburner with reheating, you can achieve like 100 kilometers a second of delta V, which means you could fly a starship single stage to Pluto and back in like less than a year, which would be pretty cool. And even with just the dumbest antimatter engine you can possibly imagine, like just the simplest possible thing. Gravity is an unusual force. Space-time is warped by mass and by energy. And there are certain ways of warping space-time that if you could warp them in that way would have the effect of essentially creating a bubble of space-time that you're able to translate through space much, much faster than the speed of light. So it's like essentially warp drive. This was most famously invented by Alcubierre as a physicist who was inspired by Star Trek to figure out what shape of space-time would allow you to do this. Once you figured out that shape, that's pretty straightforward. It's just doing some math. You have to figure out, okay, how do I actually bend space to make this shape? How do I create a matter distribution that can do this? And it turns out that all the really fun stuff in space, like warp drive, wormholes, time travel, black hole traversal, et cetera, require negative curvature. So they require you to find some way to make negative mass or negative pressure matter or something very, very exotic like that. And unfortunately, we as a species really don't even have the first idea how to go and do that, except that it almost certainly will require a lot of energy. It's unfortunate, but there's no shortage of interesting places for us to explore in the solar system this generation, and maybe we leave traveling to the stars to next generation.
It seemed very unreal to me to be there, looking back at the Earth and thinking how far, far away it was. This is the moon, that is the Earth.
Curse and the blessing of space, I guess, in some ways, in that it's not like a totally rational business. Not that like all businesses are rational, but there's something special about space.
Life cannot just be about solving one miserable problem after another. That can't be the only thing. There need to be things that inspire you, that make you glad to wake up in the morning and be part of humanity.
So I grew up watching Star Trek. I can't help it. I see humanity out amongst the stars. That is where we are going.
Arthur C. Clarke, Robert Heinlein, the sci-fi authors that really painted the picture of what this world could be like back in the 60s and 70s, those guys are still guiding our imaginations today.
And Arthur, what do you think we ought to do next? I mean, what would you like to see? A space station or Mars?
I think the first order priority is the establishment of an economical space transporter so that we can establish a large space station which would act as an astronomical observatory, which will tell us a very great deal about Mars and the other planets.
It's important that we're going and continuing to explore and have these lunar missions and Mars missions and all of these things that we've been talking about for next generations. We have to show that it's possible and not just possible once.
I used to think that was a good answer to the question of why humans want to go to space and do stuff. It could be epic bragging rights. It could be concern for a backup of the biosphere. It could be something to keep your engineers busy between wars. You know, one of the reasons NASA exists is that it's extremely difficult to generate spontaneously a crew of 20,000 people who know how to make weapons work. So you got to keep them busy in peacetime. But actually, I think if anything, running this company for a few years has taught me that like human motivations are not very well understood by humans. It's kind of obscure. People don't really know why they get up in the morning and do stuff. And so I think fundamentally the reason we explore is because that's something that humans happen to do. And it's just in our nature.
I can't speak to other species because I can't talk to them. I think we're a very creative species, and I think it's just like in our innate nature to want to explore.
At the end of the day, I think we're all too bored to stay here. I mean, that's been true since like humans were, first in Africa. I was like, well, let's go see what else is out there. Even if it's not as cool as right here, we still want to go explore it. And so regardless of business model, engineers, including myself, will continue to bang our heads on the wall of getting farther and farther away because it's like somehow ingrained in us. It's like we're hardwired, we can't help it.
Mankind was born on Earth. It was never meant to die here.
It's not a question of if, it's a matter of when. And if it's not a matter of when, then it's a matter of how long does humanity have to survive. There is some ticking clock, and we don't know where that asteroid is, or that super AI. We don't know where that is. But at some point, humanity has to separate ourselves from this planet and free ourselves and start doing the rest of the whole solar system and then the galaxy.
We're going to spread. I'm an American myself. I want it to be done by us. But in any case, the human race is going to do it. It's utterly inevitable. We're going to spread.
It's a grand painting, Mr. Heinlein.
Maybe the simplest version of it is like 13.5 billion years ago, a bunch of hydrogen atoms started colliding with one another, and now those same hydrogen atoms are thinking about the universe itself. And so the birth of the universe happened on Earth, and we have to crawl out of the primordial ooze that is this planet. And if we want to become an infant, we need to spread to a variety of planets. And if we want to become a toddler, we need to spread to a variety of solar systems. And if we want to be a teenager, it's a variety of galaxies. And if we want to become an adult, it's actually probably breaking out of this universe.
Why do you think we humans want to go to space?
I think we want to go to space because we want to explore what else is out there. Because there's so much more than what we see up in the night sky. There's like millions of miles out there that all need to be explored.